So when x is 1, we get 6 minus 4 is 2. When x is 2, we get 12 minus 4. 8. Yep. I know. When x is 3, we get 24 minus 4, which is 20. And then going back, right, we're going to get, what, 1.5. 4 minus 1.5 is, or 1.5 minus 4 is negative 2.5. This is going to be negative 3.25. And then these darn 3/8. So here, this is going to be negative 3 5/8. So a little bit more, or sorry, a little bit more negative than negative 3.5. So I'm going to graph this in purple. So 0, negative 1 is right here. 1, 2 is right there. 2, 8. 1, 2, 3, 4. 5, 6, 7, 8. There it is. And then I need 320. So it's 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wonderful. 20. There it is, 3, 20. And then going the other way, negative 2.5 right there. Negative 3.25 about there. And there. So this purple graph is y equals 3 times 2 to the x minus 4. So, same domain, range, and asymptote here. What I want to do is I want to compare these two functions here. The one in black, the y equals 2 to the x minus 4, and the one in purple, 3 times 2 to the x minus 4. Notice, y equals 2 to the x minus 4, this distance from the asymptote is 1, 2, 4, 8. The distance from the asymptote is doubling. As x gets bigger by 1, the distance from the asymptote doubles. So, here, as x goes 1 bigger, this distance goes times 2. It's not the y number that's multiplying by 2, right? 0 times 2 is not 4, but the distance from 4, or sorry, from negative 4 to 0 is 4, and then negative 4 to 4 is 8. That distance here doubles. Now, if I'm going to compare this function to this function, well, here I have a distance of 1. Here I have a distance of 3. Here I have a distance of 2. Here I have a distance of 6. Here I have a distance of 4. Here I have a distance of 12. Here I have a distance of 8. Here I have a distance of 24. So in this case, what's happening here with this y equals 3 times 2 to the x minus 4, the minus 4 moves the asymptote to y equals negative 4. The 2 to the x tells you how far your parent function, your original function, is from the asymptote. Right, so this is the base distance from the asymptote. And then what this 3 is doing, this 3 triples the base distance from the asymptote. Sorry if I'm writing off the screen there. But when we just had the 2 to the x minus 4, the distance from the asymptote went from 1, 2, 4, 8 is doubling because the base is 2. Now, when I have 3 times 2 to the x minus 4, that distance from the asymptote, the original distance being 1, 2, 4, 8, is now tripled. The distance is 3, 6, 12, 24. Okay, so let's talk about the transformations. Transformations, for this one, we would say this is still a vertical stretch by a factor of 3 for this function. And then the minus 4, what the minus 4 does, this is a translation, or we can also call it a shift down 4. We're not going to use negative 4 because the down part is a negative, so it's just down 4. The whole graph got shifted down 4, including where the asymptote is. All right, we're going to jump into one more example, well, a couple more examples. Woo. So I got to erase all this. So here we have 3 times 2 to the x plus 1 minus 4. So I'm going to leave this here. This was the table from 3 times 2 to the x minus 4. Now we're going to talk about 3 times 2 to the x minus 1 minus 4. Bum, 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 bum. Erase, 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 erase. Get out of here. Okay, come on. Okay, so this is what we had from y equals 3 times 2 to the x minus 4. Now we're changing that x to an x plus 1. So what we got to do here is you think, what is that going to do? Well, that means if I put in 0 for x, I'm taking, if x is 0 here, if I have 3 times 2 to the 0 plus 1 minus 4, that's like 3 times 2 to the 1 minus 4. So when x equals 0 here, that's like when x equals 1 in this original function. If I put in x equals 1 here, I'd have a 2 there, and that would be like this. So when x is 0, this y value is going to be 2. It's going to be when this was 1 in the original function that we just finished. So here I'm going to get 2 when x is 1, we're going to get 8. When x is 2, we're going to get 20. And then negative 1, negative 2, negative 3. Negative 1. So if I put in negative 1 here, let's say x equals negative 1, I get 3 times 2 to the negative 1 plus 1 minus 4, which is 3 times 2 to the 0 minus 4, which is 3 minus 4, which is negative 1, which originally was in this one when x was 0. So here we get negative 1, and then we're going to get negative 2.5. We're going to get negative 3.25. Blah. Sorry, I almost wrote 3.5. So if you notice, the y values between these two functions did not change. The y values are the same. What happened is we had that x plus 1, we have this x plus 1, so we're adding 1 to the variable inside. We're changing the input by plus 1. So basically what's happening is we now need, to get the same output, our x's can be 1 smaller than they used to. Because when I put a number in, I'm going to add 1 to it. And then I'm going to go 2 to that number. So if I put in 0 into this, it's really like putting 1 into this one. So I'm going to add 1, then go 2 to that. So what this does is this, instead of having these x numbers, we now have these x numbers. So I'm going to graph it, and then we're going to compare it. We're going to talk about it. So we've got 0, 2. 0, 2. There it is. There it is. And then negative 1, negative 1, negative 2, negative 2.5, negative 3, negative 3.25. We're still going to have this asymptote. We got 1, 8, 2, 4, 6, 8, and then 9, 10, 1, 2, 3, 4, 5, 6. Boom. We have this graph, which looks almost exactly like our previous graph. What happened though, right, our previous graph was right here. This is y equals 3 times 2 to the x minus 4. This graph here is y equals 3 times 2 to the x plus 1 minus 4. What happened is every point went one left. This plus 1 on the exponent, or when we change our x input by 1, by plus 1, everything in that graph can now, the inputs can now be 1 smaller to achieve the same output. Because when I put in 0 in here, it's like having a 1 in this function. So 0 here is the same as 1 on this one. So this plus 1 right there creates a translation, and also call it a shift, left 1 unit. We still have the vertical stretch by a factor of 3. We still have the shift or translation down 4. But this x plus 1 is going to shift it left 1 unit. If we had y equals 3 times 2 to the x minus 5 minus 4, what would have to happen here is all of these, any number I put in for x, is now going to be 5 smaller than what it would have been before. So if I put 5 in for x, in other words, if I'm 1, 2, 3, 4, 5 over here, 5 minus 5 is 0, I would get negative 1. And this would be, let's do a different color, 1, 2, 3, 4, 5. This would be a shift plus 5 to the right.